Good morning to everyone. So thank you for your nice introduction and praise, I think undeserved in some ways. So it's good to be here. It's good to work with young people, and because they have all kinds of interesting ideas. And today we're going to talk about product development. So far you have been dealing with your ideas from the business perspective. So starting with a value proposition for a product to be business model, different elements of the business model that you can see on the business model canvas there, that you probably know by heart by now. So I think it's time now to really deal with product to be. And I'm not getting technical right away. I know it may be a disappointment to some of you, but I will also start with modeling, just as you have been doing business modeling, business plan modeling so far. So now we will start doing product modeling or product design. And during that process of product design, then you will learn a lot about your product, about this required functionalities of your product, both hard and soft functionalities, including emotional desired functionalities of the product. But you will also learn in retrospect about your business plan. So all this what we are going to talk and do together here will feed back into your business plan and business model. So this is why modeling is extremely important, and it's not wise to go straight away to technical details and start designing the system from the technical point of view. So I hope it's all right with you. I mean, this kind of a soft approach from business issues to systems. And I know there are quite a few students with a background in economics and other areas here. So I think also for the sake of those students, it would be good to do a soft transition to technical issues. My course is entitled as Designing Social Applications as Software-Intensive Products. So why social? So I'm going to talk about it at a greater length this morning, but already when earlier this morning I heard about different product ideas that you have got here, and I would say most of them, if not all, were actually social. So they were related to interactions between people. The value that the customer would receive out of these products actually would come from social interactions between people rather than from the product as such. But the product, I mean, it's not just about between the user and the product, but it's about a bunch of stakeholders, users you may call them, but actually they are not users, they are participants. So we're talking about participatory systems where, I mean, everyone can contribute something and everyone can learn something. But I will talk about it at greater length. So the first part of my course is introduction. I've divided it into, I believe, 10 parts. So the first one is introduction. So what is it all about? So first of all, about me, there was already a nice introduction. So I will then present here my short CV. So I've received all my degrees from this university, and I worked for different research institutions in Estonia, as well as in Finland and Australia, and but also in addition to research institutions, I've also worked for private companies, and I've stayed for 8 months at the University of South Carolina, United States, as a Fulbright scholar. And currently I'm a professor in software engineering at the Department of Informatics of TTU. And this is a short list of my research areas. So they are related to software engineering for intelligent systems, multi-agent systems, ambient intelligence, agent-based mobile systems, also agent-based simulation. So this is a short overview of what I've been doing so far, and from each place where I've been, I've picked up some new ideas, particularly from Australia, but also from the United States. So these ideas about social applications, they originate in my period in the United States as a Fulbright scholar last year. So now, that was briefly about me. Now, what about you? So I think I can judge by these flags here, I mean, about the countries where I'm from. So there is no need to go into questions about where you come from. And as I've understood, so you have formed different international teams here, and you are then dealing with very interesting business and product ideas. So anything else you would like to add about yourself, or as a group, or how would you characterize yourself, or how has it been so far here? Okay, maybe too abstract a question. Yes, but anyway, it's nice to have you here. And so let's go to the essence of this course. So let's try to map the current situation. So where are we? So Alar already introduced this situation, but in a bit more detail. So where are we, or at least where should we be at the present moment? So what do we have? So I think we have identified customer segments for the product to be. Then we have value propositions for the product to be. We have identified some channels of distributing our products. We have some idea about customer relationships and stakeholders related to the product. So we should have some ideas about revenue streams, I mean where the money would come from for the product. And this can be especially hard for social applications. Like there was one, most of the applications that you have proposed are social, but particularly the one dealing with donations and non-governmental organizations, I think that was back there. So that question should be asked anyway. I mean, even if it's about donations and non-governmental organizations. You should have identified key resources for your product, key activities to be performed as a part of your business plan, key partnerships with other companies, other institutions, the government perhaps. So what kind of partnership? Is it like a partnership between, what is it based on? So is it based on some mutual interest, or is it perhaps some kind of agreement between competitors? So the different kinds of partnerships, and the cost structure of your product. So if you're going to sell it, so what does this? How can this cost for the product be divided into different fractions? So this is about business model. And now, as I said at the beginning, So, well, you have learned enough about business models, or at least you have learned a great deal about business models. But now we need to design a product. So this what I'm going to teach here is about product design. So we are going to design now our products, and during the process we will learn a lot also about the business plan. Now, about positioning of this course. Well, this is not a simple course because it is located in the intersection of different areas. So let's go through these areas briefly. So the first area, as I already mentioned, is product design. And what is product design? Well, it is a process of creating a new product to be sold by a business to its customers. So this is very straightforward. Any kind of product that can be sold on the marketplace. Then an important component is software engineering here, because the products that you have on mind, the ideas of these products, they are all software intensive products, according to my understanding. So software plays an important role in your products. So that's why we should also include software engineering in this course. And it's always good to have a definition. This is one of the possible definitions for software engineering by IEEE. And software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. And in some other definitions, the phrase by teams has been added here, meaning that software engineering is done by teams, like you have here, teams. Especially in the currently, agile software engineering is always performed in teams. Then an important component, as I already have mentioned, is social computing. And to start with, the definition of social computing is supporting social behavior through computational systems. So we support social behavior between people, social networking interactions by means of computational systems. So this is social computing. And then last but not least is intelligent systems, because we presumably we want our systems to be intelligent. So what do we mean by intelligence? Of course, this is an interesting question. So what is intelligence? Are there any good answers to this question? How would you characterize an intelligent product? Stable. Stable, yes. User intuitive, yes. Any other ideas about how do you perceive an intelligent product?
Can we dream about some kind of artificial intelligence, the system that can grow up by itself?
Of course, it's all about dreaming. All these product ideas start with dreaming. Yep. But of course, intelligence isn't necessarily about artificial life or replacing humans by robots and stuff like that, which according to my deep beliefs is not even possible. Well, we can replace humans in different activities, but not fully. But I think that intelligence is about simple things, really. For example, does your mobile phone, does your cell phone recognize the country where you are in, and does it adjust automatically to the time of the country, and even more? For example, does it recognize the switching to daylight savings time in that particular country? Well, a good example is going to Australia in spring. Well, you go to Australia in spring, and then in springtime, here in Europe, we all switch, in most, at least the countries of the European Union, we switch to daylight savings time. And then you go to Australia with your cell phone, and in many cases your cell phone is going to do it automatically. But I mean, it's in Australia, well, it's going to do the same thing. It will just move the time or push the time 1 hour ahead. And this is a totally wrong thing to do in Australia, because I mean, when it's spring here, I mean, it's autumn in Australia, and in Australia, I mean, they do the other way around. So the time is actually pushed back 1 hour. And if your cell phone recognizes this, that okay, now you're in Australia, and now it's time for ending daylight savings time, and does it by itself without the need for interruption, then I would regard this cell phone as an intelligent cell phone in this respect. So it's often about simple things rather than complicated machines replacing humans. Do you agree with it or not? So intelligent system can be defined as a system that perceives its environment and takes actions that maximize its chances of success. It's quite a good definition. I mean, perceives its environment. I mean, perceives that the environment is Australia currently. So, and you need to, then you need to act accordingly, and not to switch to summertime, but the other way around, switch back to winter time. And takes actions that maximize its chances of success. This is also very well, actually, well expressed. That you maximize, or the system maximizes its chances of success. I mean, it doesn't guarantee anything, but it tries its best to satisfy the needs by humans. Now, I already mentioned that, what we're going to do here will feed back into the business model. So everything here is intertwined. So my course isn't separate from the rest of the courses, but they are all bundled together. Now, I mentioned product design, and there can be different kinds of products. Well, of course, there can be physical products like this stand here, like those sofas here, these tables, like furniture. Furniture is an example of physical products, but of course, in some cases, furniture may have sensors, may have actuators, may have some reasoning, so that, for example, the chair might be able to change its shape according to the shape of your body. So, I mean, usually furniture belongs to the category of physical products, but there can be exceptions. Then there are digital products, like different software systems, and there are hybrid products that consist of both physical embodiment and software. Like, for example, this intelligent, maybe, digital pet here, Tamagotchi. I know it's old-fashioned, but it serves as a good example of a hybrid product where software is embedded into some physical device. Or this cell phone here, this Nokia cell phone, I mean, the same thing. There's a lot of software, a lot of intelligence, I would say, that is embedded into this physical shape. Of course, the design, if we talk about the product design in the sense of beauty of the product or elegance of the product, then this is not the best design. The iPhone has done a lot, much better job. But we do not limit ourselves here to the product design in this sense only. That it's not just about the beauty, elegance of the product, but it's more about this, the functionality, the essence of the product. So we're going to deal with product design. Now, I would like to talk about social computing. But this is a very interesting area, and I think new, fresh approaches are needed in this area. So a lot of this, those slides that will follow are actually after Professor Mike Hoons at the University of South Carolina in the United States, and he's a real guru in the area of the so-called societal or social information systems. And also one of my running examples is about a social information system that helps people in grocery shopping. So the grand problems that our society is faced with today, I mean, they are related to several areas. I mean, they are related to economy. There are, I mean, issues about prices, taxes, and credit, as you know, all these problems with the Eurozone and so on. Banking, they are related to energy, distribution and allocation of energy. Looks like the energy market is going to be more distributed in the near future, where you can choose the place where you buy your energy. And there are different providers of energy, including small providers of wind energy as well as solar energy. Environment is a big problem, pollution control, carbon allowances and water allocation. Transportation, logistics, I mean, how to transport people and goods, I mean, it's getting more and more complicated. Telecommunication systems, bandwidth required increases all the time. So what is common for these challenges? So how would you characterize these different challenges of the current world, present world?
A lot of participants.
Yes, yep, yes. Yes, there are a lot of participants. I mean, these are all distributed domains. And as distributed domains, they should be addressed in a distributed way. But unfortunately, they are far too often are still addressed in a centralized rather than distributed way. And I'm convinced that this is the reason for many of the problems in today's world. That these problems that are by nature are distributed, they are still being tried to solve in a centralized manner. Well, for example, let's take a simple example, shopping applications. Well, there are shopping applications around. I mean, it's not a new thing. There are applications like, for example, the one that is shown here, where you can enter your product and then you find similar products sold at different stores. But actually, well, this product is not social in the sense that, well, just these different products you can see here, I mean, they are retrieved from different websites, pretty much in the way that Google retrieves information, and that's it. But they are categorized, they are presented in a systematic way, and of course it's mobile, is an advantage. But I think a lot more can be done with shopping applications of this kind. I think if the input would come from individuals rather than some centralized systems like Google, well, I think we could improve the quality of life of everyone. And I will talk about one example in more detail. As I said, it's going to be one of my running examples. Well, I already mentioned Google. There are also other applications, Facebook, Twitter, LinkedIn, and so on, but they are all centralized applications. And I've seen actually an interesting TV program by BBC, I believe, where the founder of Internet, Tim Berners-Lee, actually expressed his regret about this, the development in Internet, because in his opinion the Internet actually hasn't developed the way it should have developed. I mean, because the Internet has become, well, it was democratic at first, so everyone could say something, I mean, everyone could participate, but you know, well, you probably don't remember, but you may know that there was an area of bulletin boards, and everyone could set up one, and you could exchange information and so on. So in some some ways it was more democratic. But now these big players have taken up actually the lion's share of the internet. And there is not much space for really social interactions in the internet. Of course, Facebook and so on, you can interact in Facebook, but you are followed actually all the time. I mean, you do not have any privacy really. I mean, what you type, I mean, this is used for advertising, so you get constant in-feed of different advertisements and so on. So it's not really what it should be. And I know there are attempts to create alternatives to Facebook, for example, that more respect people's privacy, and that have been designed in a peer-to-peer manner. Like Skype has been designed in a peer-to-peer manner, and I think this is one way to go actually, rather than having the centralized client-server systems, to have the peer-to-peer systems which are more democratic by nature. These different centralized systems, though they process the information at their disposal in their own interests and share it between the participants only selectively. Well, this is actually a good discussion point here, or maybe you have some ideas or want to argue with me about it. You use Facebook more than I do, so I'm the so-called kind of ascetic user of Facebook, so I have it, but don't use it too frequently. Simply don't have time. Yes.
But isn't it natural to centralize? I mean, how do you control the way? Isn't it all about money? If you have a distributed system, how you earn money? If you have a centralized, then you can control all the parts, and you can prognose, and you can actually get money from it.
Yeah. It's a good question actually. Yes, there are social applications. How do they really earn money? It's a good question, because I know there have been attempts in Australia also. To study these social applications, and they have worked out some very good examples, proof of concept prototypes, and then they have also come across this problem of revenue, where to get money. But I think there can be solutions to this also. Maybe this is where you need to come in and propose some ideas for revenues for the social applications. So I'm convinced it can be done. Maybe through donations, for example, the free software, open software, the market works quite well, or maybe some normal controlled prices, because all these centralized places, they tend to have as high prices as possible. So I think this is a part of your exercise here actually, to try to come up with these ideas for revenue streams for social applications. But it was a good question. Okay, now more specifically, what kinds of problems am I talking about? Well, we can take a simple thing as finding parking spaces, for example. It is a big problem actually to find a parking spot in a big city, and even in Tallinn, which is not so big, and it's hard to find a parking spot. So you can actually end up driving around for half an hour or so just in search of a parking spot. And it's uncomfortable but also dangerous, especially for someone with relatively slow reactions like me. It's not nice at all. But maybe we can do something with social applications here. And in the United States, when I was there as a Fulbright scholar, then we investigated possible applications where commuters or drivers would actually inform other commuters about parking spots. So meaning that they would, the driver would inform other drivers through some social networking system that a given that are just freed a given parking spot in the given location. And actually to identify the location is easy these days with the GPS, or even when there is no GPS, then with positioning that each mobile phone has some positioning. It's quite rough, but still works. So if drivers, commuters would inform each other about parking spaces taken or freed, then the situation would improve. But of course, there is a need for incentives. So how to make sure that one would do it? So it's not that easy. It's easy in theory, but in practice, how to make sure that people would contribute in the hope of getting also something back from other people or from other commuters in this case. Then distributed situation assessment, for example, traffic jams. So one of the very good real-life examples, this comes from Estonia. A couple of years ago, we had a severe snowstorm here in winter, and this was quite unexpected. So that in one particular spot in northeastern part of Estonia, it's a hollow, and in that spot many cars got stuck. And the reason was that, well, first of all, some truck broke down ahead, and then these cars behind it, so they didn't know what was going on. The drivers were just thinking that, okay, someone was going too slow, and then they started to pass that truck, but there was no visibility, and then there were cars coming in the other direction, and then it all ended up in a huge traffic jam, and finally the people had to be rescued by the Estonian army. Because there was the snowstorm kept building up, and there was no access of any kind. So only army had vehicles that could access people and rescue them from the cars. So I think that situations like this could have been avoided by some smart systems that each car could have. Some smart system that knows about that knows about the situation through interacting with the same kind of smart systems or similar kind of smart systems on other cars. And through these interactions, they develop the so-called situation awareness of the situation as a whole, because each car can see only, or each driver can see only a part of the situation, but altogether they can develop the picture of the situation as a whole. And then the driver, if the driver knows, if the system, intelligent system, informs the driver that please don't pass because they will be stuck. There is no way to pass, just wait here, then situations like this could have been avoided. And also, the same is true for big traffic jams. Like, we haven't got as big traffic jams here, but traffic jams of the kind I've seen in Shanghai, for example. Then decentralized decision making, like finding a grocery store that is appropriate for my given food basket, the products I would like to buy for me and my family. Also legal decision making, taxation, intelligent traffic control, also in the sense that the traffic control would be built up in a distributed way and would honor all drivers rather than only drivers moving on certain roads which have been given priorities. Because in many cases, well, you see that that certain roads the cars can move quite freely, but then there's some other crossing roads where there can be more traffic even, then the cars actually they have to wait for a long time before they can cross. So all this can be regulated in a distributed way, in a much better fashion. and cooperative information exchange. Because currently, if you search for information in Google, for example, then, well, you get many hits, and it works well, but there are no real interactions with other users involved. And through these kinds of interactions, I think you could get much better hits, even if other users, other searchers of information would have a facility to inform you about the relevant things. So the question is, what kinds of systems would be needed, really? And I would define these systems as the ones that obtain control information from the edges of the system, that is from individuals, from people at the edges, process that information and feed that information back to the edges. So the information comes from people, participants, consumers, patients, drivers, commuters, whatever, and the information is processed somewhere, and this processing can be distributed or can be centralized, but what matters is that the information is fed back to those individuals and works in the interests of those individuals rather than in the interests of some centralized players. So this is the main idea of social information systems. Examples, for example, electricity distribution. Well, electricity distribution is done centrally these days. So it means there is some big player like Estonian energy company in the case of Estonia, and who distributes energy and holds the monopoly to energy distribution. And this means that there is not much flexibility. But actually, for example, if we think from the perspective of environment, for example, and how to not to overproduce energy. For example, if I'm on holidays, I don't consume any energy, then, well, in principle, this share of energy that would be allocated to me could be allocated to someone else. Or let's take blackouts or brownouts in a very frequent thing in the United States, also in some European countries, in Southern Europe, I believe. When there is not enough energy, then someone decides centrally that, okay, we're going to shut off these households, or partially, we're going to partially shut them off, maybe. So someone centrally takes the decision for blackouts, and not considering, is there a family with small children, maybe? It's so hard to cope with a family with small children without electricity, I know from my own hand, or maybe elderly people, or maybe there are some systems that support elderly people and that need energy, constant energy, and they're just shut off, without any consideration. So how should this problem be approached? Well, I think that if that would be distributed, so if somehow the information about this situation, different situations on the edges, with situations with particular consumers, if that would be registered and would be passed to the energy company, then the energy company would then take decisions accordingly. For example, if some family has left to the countryside for summer, then their household can be the electricity can be shut off more easily. Of course, there can be problems, like there can be freeze and so on, but these problems can be more easily overcome compared to the families with children or with elderly people, for example. So just an example. Grocery shopping, I'm going to talk more about it today. Healthcare is an interesting domain. So how to come up with the systems that would enable patients to choose healthcare providers based on the feedback by other patients in a systematic way. So I'm not talking about the ad hoc way, how it is done in social networking currently, Facebook and so on, but in a systematic, automated way. Transportation, I already mentioned. Traffic control, also already mentioned. Telecom bandwidth, how to allocate it according to the real need, rather than perceived need by some central entity. So to deal with all these problems, we need a design approach. So we need an approach how to design societal information systems of this kind. And as I perceived, many of your ideas were also in this direction. So I hope that maybe this is at least thought-provoking, so what I'm telling here. Okay, now, are there any questions here?
Do I understand correctly that you more rely on the automatic or inputs that automatically gather information, not users entering some commands or...
Yes, yeah. Yes, well, because in such systems, I mean, there is a lot of information needs to be processed. Well, I mean, first of all, the information needs to be gathered from the nodes representing individuals. If we talk about this like a network consisting of different nodes, each node represents an individual. We need to gather information, and this gathering should also be automated. So we should use sensors as much as possible, rather than relying on users typing in information. But then when it comes to processing that information, again, this is an overwhelming task, and no individual can cope with it. So the individuals need assistance, intelligent assistance. And I call such assistants agents. I will talk more about agents today. So these agents would help individuals to cope with distributed problems. So this means that, well, basically I delegate this information processing to my agent, because the word agent by definition means is someone representing me. So I delegate it to my agent, and they takes care of it. Of course, there are issues of trust. Can I trust my agent? Can agents trust each other, and so on? But this is the way to go. So any other comments or questions? So this was emphasizing social aspect of what we are doing here. And now, so the question is, so how to do it? So this was an introduction, I mean, so, kind of a general overview. But now about how to design such systems, or how to design software-intensive products in more general. So I do not actually limit my approach to social information systems only, but actually to all kinds of software-intensive systems. And also, this approach is not limited to just multi-agent systems or systems of artificial intelligence, but I use this term agent as an abstraction rather than as only meaning this intelligent software agent that I just mentioned. But of course, it also includes these intelligent software agents. But we will learn about it, and we will also do some exercises about it. Now, this kind of design approach that is needed is proposed in this book, which is entitled The Art of Agent-Oriented Modeling. It is it's co-authored by me and my good colleague from Australia, Leon Sterling. And in fact, you will hear Leon Sterling speaking tomorrow over video conference about software quality. And he's a very distinguished lecturer, and I think it will be very interesting. And he actually likes to do it in an interactive way. So there will be a microphone in the audience, and I will pass it around. So I hope you will participate a lot. So he's really very very entertaining and very interesting presenter. So Leon and I have written a book which is entitled The Art of Agent-Oriented Modeling. And in this book, what we do, well, we describe how to design systems of the kind I was trying to introduce here. I mean, systems that are social, intelligent, that are software intensive, and that help people as well as companies in their everyday activities. So we're talking about distributed information systems, an approach how to design such distributed information systems. And the publisher is here is MIT Press. And you can actually, just a little advertisement, you can actually buy this also from Amazon and other online bookstores. So, I mean, who doesn't advertise his own book? Just to repeat it over, so the book's mission is to address computing in current distributed environments where the computing is pervasive, deployed over a range of devices. There are different devices. I think all of you here, I can see many devices, both mobile devices and PDAs, tablet computers, laptops, and so on. And there are many users. So the landscape has changed. I mean, in this sense, I mean, we do not rely on desktops anymore, but we have become mobile. We move around with different kinds of devices. And even more important is that these systems have become open, meaning that everyone can join, everyone can opt out at any time. So, and we need a software engineering approach that is able to deal with this kind of landscape. And the landscape, the keywords that characterize the landscape are the systems are open, they are intelligent, and adaptive. So I haven't yet mentioned adaptiveness, because the systems should adapt to the changes. The changes can occur suddenly, and the system has to adapt to that change also. And this is a big problem in current software systems. They are not adaptive enough, do not adapt to changes in the environment or changes pertaining to the user. So now about the running examples. I think we are well on schedule. So there are two running examples that I'm going to use here. So the first running example is this digital pet Tamagotchi I mentioned here, and I've chosen it because it is on one hand it is physical, but this physical body here, this embodies software, embodies something I would call intelligence, or of course you may ask, I mean, is this digital pet really intelligent? Well, I've got this idea of using this digital pet as a case study from my daughters who were, I mean, then when I was writing the book, I think they were 6 and 9, I think, and then they were playing with Tamagotchis, and this actually impressed me as a good example of an intelligent product. And now when it comes to intelligence, then well, I asked my elder daughter, at some stage, so do you think is Tamagotchi intelligent? And well, without any hesitation, without any second, I mean, well, she answered that, yes, of course, Daddy, I mean, it's intelligent, it can do so many things, I mean, you can feed it, I mean, it can interact with you, I mean, it can ask things, it can ask for food, ask for fellowship, friendship, ask to get acquainted with other digital pets, other Tamagotchis, so of course it is. So, and of course, my daughter was then old enough to have this kind of understanding of what is intelligence. So there was no doubt. So, and I think it's a good way to define intelligence, just to ask someone, I mean, who is dealing with the system, using the system, and ask the person, do you think the system is intelligent? Then, another example is a societal information system for grocery shopping. And that is an example of a societal or social information system that I have been referring to. And I think it's relevant for also many of the systems you are dealing here in Teams. Well, to talk more about Tamagotchis first, well, this photo here shows how these two Tamagotchis interact with each other. But basically, there is an infrared connection. And here, what you can see is actually that the one digital pet has left, left its home and has actually entered the home of other digital pet. The home is the box here, and here they are singing together. So this is what is going on here. So, well, of course, I mean, it's a simple. On one hand, it's a simple simulation, but on the other hand, well, it is some kind of system that mimics real life, that has educational value for small kids, maybe for their parents even. So, so it is really a very, I would say, even complicated and interesting system, because you do not know what is going to happen really. I mean, of course, it's all based on some algorithms, some software, but from the user's point of view, you do not know, I mean, what's going to happen and what mood your digital pet will be in. Okay, and this is the Tamagotchi environment. You can enter with your digital pet some environment, online environment, where you can virtualize your digital pet. Another interesting concept is virtualizing your pet. You just, you just enter some combination of characters and letters that your digital pet generates, I mean, from this device here, and then you enter with this code into this environment, and then your Tamagotchi becomes virtualized in the environment. So that was Tamagotchi. I think it's a pretty easy case study. I think many of you maybe have played with these kinds of toys in your childhood. So am I right? Is it familiar with this? I know it's kind of outdated now, but it still serves as a good example. The second example is grocery shopping. And the grocery shopping is an example of a social information system. And the basic idea is the following one. The customers post the prices they paid for their groceries, and also quality of service information, meaning that was there a good service at a particular store? Would it go back there or not? Then a prospective shopper enters a grocery list reflecting her or his needs. So your typical grocery list, what products do you buy as a rule? So what is your food basket? You enter your grocery list to that system, and then you obtain a pointer to the combination of stores with the lowest total price and best service also. So there are different factors here. And then, well, you get this list. You also get the route. Okay, please, route saying that drive to this supermarket first, and then to the other one, and then to the third one, perhaps. And that is the optimal route from the point of view of fuel consumption. So you drive through these stores, and then you obtained your commodities for an overall optimal price. So how to do it in practical life? Well, obviously there is a lot of information processing involved here, and a solution would be for each customer to have an agent, intelligent software entity that represents the interests of that customer and interacts with agents representing other customers. And well, you may say it's kind of science fiction, but Professor Mike Hoons at the University of South Carolina and one of his PhD students, they carried out some simulations, and they've using real data from data actually gathered from real supermarkets. And they found that through this kind of system, savings up to 21% can be obtained. And this includes fuel cost. So fuel cost is included here. I mean, you drive around, you buy a bunch of products from one store, another bunch from another store, maybe you're going to the third store also to buy some more, and your overall savings can be up to 21%. So this is one of the running examples, and just a visualization. I mean, how it works. So you have well, actually, just a remark about the implementation. As you can see, I mean, this is pretty much centralized. There is a product database. So because this is about architecture, these are two different things. So one thing is the conceptual. Conceptually it is distributed, but when we're going to the implementation, to the architecture of the system, well, we can use some centralized architecture, and this is all right, but the important thing is, I mean, how it is conceptually. So here, well, different customers, they go to supermarkets, stores, then they have mobile devices. They obtain product information from that, some sort of product database about different products, and then somehow they register the prices for different products. And now this is a crucial point here, because this needs to be automated. We cannot rely on customers just entering these prices, but this needs to be automated. And as you may know, these barcodes, they usually do not include price information. So this is one open issue here. But basically, they somehow read the price information, and this is forwarded to the price and feedback database here, and then it is used by other customers, so that they know, I mean, what are the prices for products in different stores. And you may ask, why not to connect it to the databases by stores? For a simple reason, because stores are not always honest about their prices, and because their goal is to attract as many customers as possible. But if we rely on customers doing it and informing each other, then the results will be more trustworthy. Of course, someone can actually come and start actually mixing up the thing, and doing like inserting false prices, false information, and so on. So this is all possible. But I think somehow these such problems can also be solved.